All right, welcome to The Explainer. Today, we are digging into a really fascinating and kind of tricky challenge in AI. And that is, how do you actually teach an AI to be creative? To really explore when it's trying to solve a problem.
Okay, so take a look at this situation. We've got this AI agent, and its job, well, it's super simple. Just get to that green square. Easy, right? But it's completely stuck. It just keeps bumping its head against that wall again and again. And this simple little puzzle, it actually shines a huge spotlight on a major roadblock in how we teach AI to think.
So yeah, why do they get stuck like this? What's going on under the hood?
Well, to really get it, we've got to first understand how these AIs learn to find their way around in the first place. It all boils down to this thing called reinforcement learning, or RL. And honestly, the best way to think about it is like training a dog. It does something good, you give it a treat. The AI tries some action, and if that action gets it closer to its goal, boom, it gets a reward. It's all about trial and error. But the real key here, the secret sauce, is exploration. It has to try a bunch of different things to figure out which path leads to the biggest pile of treats.
But here's where it gets sticky. The agent figures out pretty quickly that moving towards the green square is good. It gets a little reward for that. But to get around that wall, it actually has to move away from the goal first. And in its little AI brain, that feels like a bad move, like it's being punished. So it gets trapped in what we call a local optimum. It's a strategy that looks pretty good right now, but it's a total dead end in the long run.
Okay, so if one agent gets stuck, what's the obvious solution? Well, throw a whole team of AIs at the problem, right? Makes sense. A whole population could explore together and cover way more ground. But this is where we run into the problem with teamwork. Because, as you're about to see, how you tell them to cooperate is absolutely critical.
So the old school strategy was, super straightforward. Basically, you just tell every agent, hey, stay as far away from your nearest teammate as you can. The idea was, okay, this will force them to spread out, they'll cover different areas, problem solved. But this super simple rule has a couple of really big and kind of surprising flaws.
First off, you get this weird clumping thing happening. The agents form these little groups, and yeah, the groups are far away from each other. But here's the catch. Everyone inside one of those groups is doing the exact same thing. They're all bumping their heads against the same wall. It's a huge waste of time and energy. They're just rediscovering the same failed ideas over and over.
And the other big problem? Well, it's just uncreative. The agents spread out, sure, but they do it in this really predictable, kind of boring way. You can almost see it here. It's like they're just forming a big circle. They're all far from their neighbors, which was the rule, but they're not actually exploring the space in a genuinely diverse or creative way. They're completely missing the complex, clever solution that's hiding right under their noses.
So here's the bottom line. Even though on the surface, the agents look like they're spread out, if you just measure the distance between them, their collective strategy, the way they're exploring as a team, is actually really, really weak. It's not truly diverse at all.
So, how do we fix this whole mess? This is where things get really cool. A new playbook for diversity enters the picture. It's a brand new approach called diversity via determinants, or just DVD for short. And it basically throws out the old rulebook and gives the team a completely different way to think about working together.
And what's so powerful here is the massive shift in thinking. The old way, on the left, was basically a selfish instruction. Just worry about yourself and your nearest neighbor. But the new DVD way, it's a collective goal for the whole team. Let's maximize the space we cover together.
Think about it like this. The old way is like telling a team of treasure hunters, hey, just make sure you're not standing next to anybody else. The new way is like saying, okay, team, our goal is to explore and map out the biggest possible area of this island together. It's all about maximizing the team's total coverage, not individual distances.
And this gets to the math behind the magic. That word determinant might sound a little scary, but it's really just a clever tool from mathematics. In this context, it calculates the volume of the space covered by the whole team's combined behaviors. It's a way to measure their collective footprint. A bigger volume means more genuine, useful diversity. All right, so this new playbook sounds great in theory, but it leads to way smarter robots and much better results in the real world. So let's actually see how this whole strategy plays out in practice. And trust me, the outcomes are pretty amazing. So, the big question, right? Does all this fancy math actually work? Does it really make these AI agents any smarter? Can it help them solve those problems they were completely stuck on before?
And the answer is a huge resounding yes. Remember that little agent stuck at the wall from the beginning? The one that stumped the other methods?
Well, this graph on the right shows that DPVD cracks it, no problem. It consistently learns to go around the wall and get that big reward.
But wait, it gets even cooler. DVD isn't just about finding one good solution. Because it's designed to reward a whole range of different behaviors, it can actually discover multiple high-quality solutions all at the same time. For instance, it can teach this little ant robot to walk forwards really well, and also teach it how to walk backwards just as well, all in the same training run.
Okay, but this is the result that really makes you go, wow. This is the humanoid task, and it's famous for being incredibly hard. Most algorithms just get stuck. The robot learns to this kind of stand still, maybe wobble a bit to collect a tiny survival bonus reward. But look at that blue line. DVD is the first algorithm to get this humanoid to actually learn to run forward, and it does it in just 1,000,000 steps, which is incredibly fast.
And just to put that number in perspective for you, a score of around 5,000 basically means the robot is just standing there, not falling over. But a score over 6,000, which is what DVD hits, that means it has figured out how to actually move, how to run. That is a massive, massive leap in performance.
So, okay, this is all very cool for robots and simulations, but why does it really matter? What's the big picture here? What does this new way of thinking about diversity mean for the future of AI?
Well, the success of DVD really comes down to a few brilliant ideas. First, by thinking about the whole team at once, it completely avoids those inefficient little clumps we saw before. It also uses a really smart, universal way to define what behavior even means. And maybe most importantly, it's constantly intelligently balancing the need to explore for new ideas with the need to cash in on the best ideas it's already found.
And look, this is about so much more than just making robots run around in a computer. This is a huge step toward building AI that is more robust, more creative, and just more efficient. The kind of AI that could help us solve really complex, open-ended problems in the real world. Think medicine, engineering, or even fundamental science.
Which, leaves us with a pretty deep question to think about. By changing the rules from a simple stay away from each other to a collective let's cover more ground together, we aren't just getting higher scores in a simulation. We are fundamentally teaching our AI a new, more collaborative way to think. And it really makes you wonder, when we finally unleash that kind of creative, team-based exploration on some of the world's biggest challenges, what are they gonna discover?